Hello, everyone. We are Team Dynamic Entropy, and our team is myself, Hassan, Jared, Matthias, and Clement. And we all came from a different background. Some of us is from statistics and engineering background, some others from construction. And we all came together to solve the problem, which is about forecasting the durations of the project and trying to reduce the variation in these durations. It's the problem in the industry is widely involved with 60% duration overrun. 60% of the projects are lacking predictability. So we're basically trying to understand or solve two problems. One is understanding the features which affect the duration variances, as the other one is deploying a machine learning algorithm that can predict duration quite accurately. Handing over.
Hi, I'm Jared. So to tackle the first problem here, to see which are the main drivers for the duration delay and stuff like that, we developed an app in Shiny. Hassan, yep, there you go. So what this does is essentially does simple linear regression for a response variable of your choice and your predictor variable of your choice. This is also based on an input data set that you can upload yourself. And then this spits out information telling you which values in the category give you an increase in your response variable and a decrease in the response variable. And this is a web-based app deployed online as of now.
And hello, and about the use case of these models, we envision two use cases. One is going to be aimed at project managers, and the idea is that one of the biggest problems Hassan has identified is that a lot of the projects controls use outdated information. So we developed a model, and we envision an app that is going to feed all the historical data for each project and all historical data for all previous projects, and every time just updates the predictions and give early warnings to the users about any upcoming issues or delays. And the second application we envision, if we can show that, Hassan, and is for planners at the onset of the project. So the idea here is planners can actually upload all previous data from previous projects, and based on the features of this project, the algorithm is going to tell them whether they're being overly optimistic for some activities, and they can correct their forecasts accordingly.
Okay, yeah, I will walk you through how we tackled this and how we came up with our solution. So the first step was to simply clean the data and create some new high-level features based on the data that was given. With this data, we then created a machine learning model directly in AzureML Studio. And this is a cloud-based solution which is highly scalable. And in our case, we deployed it into an interactive Access spreadsheet that can directly be used by the planner. The way we validated this is we split up the data into 70-30 to have a test set of unseen data. And using this data, we saw that we can achieve a reduction in duration variance by 84%. And by a rule of thumb, we try to estimate the cost of the estimated cost reduction based on this. And we figure out the 8.4% reduction in cost. What you see here is the model that we eventually used, a random forest that achieved the R-squared value of 0.856 and the RMSE of 0.1.
All right. So just to wrap it up, I think it is a highly practical problem that we face in the construction every day. The solution that we propose will give early warnings and a sort of a leading indicator for the construction project managers, but will also point them to the areas where they can do preventive and mitigation measures. We can see a reduction in cost and time for delivery, but certainly what we will see as a result of this application is increase of certainty of contractors and protection and of revenues and protection against losses. But overall, I think this application, if widely used, will help the construction sector and the construction industry in general to improve predictability and validate output. Thank you.
The first question, which is how would you portray the confidence in the forecast that that planner can take a judgment call? is we've actually used the observed data here. We split it into a test data set and a training data set. And then once we trained the model, we then applied it into the unseen data, and we actually have received better predictions at the duration of an activity than the initial planned durations. I think, and this proves the confidence in our forecasts and in our estimations. And I think the planner can take this into account, look at the drivers as well, and then see what can delay a project or not. And the second question is, how would you envisage being able to develop this further so that is dynamic? What additional fields would you need? Flamen, would you?
Yeah, so this question has two parts, obviously. So how to develop this to be dynamic? Well, we already envisioned it to be dynamic. So the way we're actually feeding data is for each activity, we actually looking dynamically at the past performance of similar activities into the project. And as the new data comes in, it will can be recalculated. It's also cloud-based. So every time new data comes in, it takes just a couple of minutes to retrain the whole model. So it's already envisioned to be dynamic. What additional fields do we need? Well, at the moment, the data is obviously anonymous, so some of the fields are coded. It would be very nice to have for instance, the kind of, we don't know the activities or the departments they're in. So we should be able to see more, get the kind of predictability if we know them, and also on top of it, more behavioral fields will be also helpful for accuracy. Thank you.